audible?
Yes, sir.
So first of all, did you get what is that I was referring to in the IP? Months. Suppose the reference book. Hello, am I audible?
Yes, sir.
Yes, sir.
Yeah. So uh, the reference book which you would be predominantly using for this course would be on CMOS, digital integrated circuits, analysis and design. Please note down, it's CMOS, digital integrated circuit, analysis and design. That's by Sung Moo Kang and Yusuf Leble BC. Okay, so this would be the predominant book which shall be followed, uh, which shall be followed for this course. Okay, so I think yeah, I think Mansa is. So can you open Mansa? I mean, like you're sharing something. We had actually had a discussion last time, so just wanted you to know a few of those things. Can you just open up?
Yes, sir.
So possibly you can do it from the second one. Yeah, I mean whether you. So as far as your marks distribution for this course is concerned, I think you will have a mid-semester and a minor, and then the final exam. So final exam is always fixed for 50. or the weightage is around 50, while your minor one and midterm shall be dependent on whether you're going to have a lab session for this or not. So to begin with, I think, yeah, did you open your screen? I can't see. Answer?
Sir, I am presenting my screen right now. Like I have opened information technology.
Ah, but I can't see.
Now,
No, not me, everybody.
sir, if someone else can confirm because I am presenting the screen right now.
I can see.
It's visible.
Manali, can you see?
Yes, sir.
Okay. How come I am not able to see? Mansa, can you just share once again?
Yes, sir.
Is it on my smartphone? I cannot see it at all. Is that so?
I don't think that would be a problem because many of us are used
Okay, go.
like using. Sir, now
Hmm. I can see all those who are attending. Almost there are 20, 25 people are there, but I don't see. Where do you get it? I mean, like, am I missing on something? Because most of the times I'm displaying and the others are seeing. So I do not know probably if I'm missing on something.
no, like whoever presents the screen, it just is visible by default.
So the rest of you can see this.
Yes, sir.
Yes, sir.
Okay, so what do you see?
Sir, about information
Yes.
technology.
So many of you are leaving. Is there any issue? I can only hear background noise.
So like right now, I am presenting the information technology, right? That thing.
Okay, so what is there in that? I actually can't see anything. Let me relog in once again, huh?
Yeah, yeah.
Jitendra, कौन सा वो लैपटॉप ले गया? लॉगिन करना है फिर ये वाला लिंक अपने जीमेल पे ही कर दो, मैं तुम्हें जीमेल पे भेज देता हूँ. AI आगे हम्म ये लिखना मेरे को टाइम चलता है बोल उन्होंने या आइए इधर इसके लिए सोचिए इसके बारे में हेलो am I audible? Actually I've asked one of my students, let it be. I've asked one of my students, so probably if this is working. Are you people there?
Yes, sir.
Yes, sir.
Okay. Now can you display that? So now you can see actually. So that day we were talking about the whole stuff. First of all, I would like to know from you students, since you're now in third year and probably going to fourth year, so you're already finishing with your bachelor's degree. So what is the basic difference between, say, electrical and electronics engineering, or electrical and electronics per se. Yeah, tell me. Hello, am I audible? Aman, Premlata, Manas,
Yes, sir.
tell me. Tell me, what's the basic difference when you're talking about electrical and electronics? Is there a difference, first of all? Do you think there is any difference, or is just like that people are Navratan?
Yes, sir. So actually,
Tell me.
electrical circuit can't control their decision making because it just produce electricity and flow through powerful components. Meanwhile, the electronic circuit can control their own uh, decision making, and they can assign data to instructions, and there are mainly uh, so contains some active unit like diode and transistor, etc. So that control their own decision making.
I don't know what you said, but it's not clear to me. Anybody else? Premlata, Aniket, Aman,
Yes, sir. So electronic circuits are.
Rishabh?
Sir, am I audible?
No, basics electrical and electronics. I'm not talking about circuits and all. Circuits can be both in electrical and electronics.
Electronics mean we have logical dependency, and electrical does not have logical dependency. It just deals with the electricity generation part. In short,
What do you mean by saying that? Suppose you're talking about within your own room at this moment of time, or in your university campus, or some of the other places. What are devices that you talk about is electronics, and which one are electrical,
so
and
most of
why
the
so?
devices nowadays are a combination of them both.
Okay, but still, can you just tell me exclusive ones? See, I don't want people to just talk about some adjective words, or in circles. If you do not know, then only you will go in circles, or you try to be diplomatic, or something. You can rework your stuff and then answer, or maybe you say you do not know, or maybe just read now or try to understand now. You're almost in your third year, so I would want some kind of a clarity. Yeah, go ahead, Aman.
Yeah, so electrical example could be like a light bulb.
What
So
type of
because
light
it's
bulb?
a
What type
normal
of light
plane,
bulb?
the orange
What
one.
is, what is this normal plain light bulb?
So the one which has just the filament and the electricity passes through it and heats it up to produce light.
Okay, that is basically called as incandescent bulb, or not? You have some kind of a wire there which gets heated up, and then because of that heat, you have basically uh, light in, and that can be measured in a particular unit. So why is it electrical? Okay, fine.
So because it just uses electricity, it doesn't have any sort of
Just
switch.
uses electricity.
It doesn't control the intensity of the heat or the light, right?
So that is why
Like
it is
it,
called electrical.
I think so.
Okay, Tarun, Manas.
Electronics, we generally talk about active devices like diodes, transistors. Like we make electronics, like the movement of electrons in these active devices, how they are used for power amplification, and operational amplifiers, and these things we talk about in electronics. In electrical engineering, generally we talk about passive devices like capacitors and resistors, and the power generated in the as these devices are used, or also electromagnetism we talk about in electrical engineering.
Again, I think you are partially, some things are right, but you've not got the exact understanding. So you mean to say, can you give some example? I mean, like partially why I said it was right is because you talked about active devices. Okay, so active devices like what you said?
Diodes,
Uh-huh.
operational amplifiers.
Operational amplifier is what?
I mean,
It is made up of what?
it's made up of diodes, and I mean,
Operational amplifiers are made up of diodes.
no, sir, I'm not saying that. I mean, it's I don't think so. It's made up of, and something say it's in itself a component, electrical component. It's available like that.
When did you study this?
Yes.
Any other? Yeah, Ishan, I just saw you coming in, joining in.
I just joined. I was having a little bit of trouble with my internet.
No
So,
issues, no issues.
sir, I don't know what we're talking about.
We are talking about the basic difference between electrical and electronics engineering. Very basic difference. Why do we call electrical as electrical and electronics as electronics? And I think a few of you tried to do that. So it's we are all learning. So I just wanted to first get basic, what doing actually. And then I also, I mean, like I was actually, after talking to you, I also talked to Manasa, and that is how we got into all these things. So first of all, I want to know what exactly, because until unless you know those kind of things, I mean, like at least in first introductory classes, first few introductory classes, you should be clear about the IP, electrical, electronics, and what all we are doing and why. Okay, and it's a part and parcel even for the whole of your other courses that you're doing or have done or would be doing in near future. So what is the basic difference, or some of the fundamental difference that you see when you talk in terms of electrical? Just give by taking examples which you can see right away, right now, inside your house or home or your workplace that you are uh, present at this moment of time. Am I audible? Yeah, go
Yes,
ahead,
sir.
Ishan. Yeah, go ahead, Ishan.
Sir, I actually don't know what the clear basic difference is between the two.
Okay, can you cite some examples? I think Manas did start with that,
Sir,
but he kind
actually,
of mixed up with this few other things.
I mean, this
Please be louder, huh? Bolo, bolo. No problem.
operational amplifiers, like any other amplifier, is made up of transistors. I mean,
Everything. Okay. So let's just talk about fundamentals first. Then we go into deeper. Yeah, you're right now. So previously you were saying something else. I mean, I was not able to.
I mean, I was confused between two things. Like what was
So
the
what is the basic difference between electrical and electronics? Sai Sudhir or Manas, you just carry on from where you left. Good. Electrical needs conductor and electronics needs conductor. ये कब पढ़ा है भैया आपने? When did you study all this? So you mean to say within electronics there is no conductor? Huh. Okay, can you again, Premlata, Aman, Manas, Ishan,
Sir,
Navratan, Mansa, Mansi, Can you just give me a few examples of pure electrical and electronics, and don't try to mix up things so that again you would not have the clarity. Be frank, just try to figure it out and just tell me. Just from the live
Sir,
examples from within your home itself.
it's like circuit theory comes under electrical, but when we use that circuit theory to, let's say, power a speaker or something, it comes under electronics.
Circuit theory would be true for anything and everything, isn't it?
Sir, yes, but the study of that would come under electrical.
Okay, now let's talk about, somebody did mention about bulb.
The
So
bulbs, electrical switches, and
hang on. Let's take one example at a time. I mean, you just try to you make mix up and then you have no idea what you're talking about, or we are learning every day. Yeah, so Candace bulb. So what is generally, I mean, like, do we have a resistor there? What is actually happening there? Let's talk very simple fundamental examples, and please make
Sir,
it
we have a
fast.
filament that heats up and
Why
converts
does it
things
heat?
into.
Why does it gets heated up?
Sir, because it has a high melting point.
Electrical
If
energy
it
is
is,
getting converted.
yeah,
Electrical
Aditya
energy
Raj.
is getting converted to light.
Electrical energy, and how is it happening? What is filament acting as? Is it acting as a conductor or a resistor or a transducer? You know what's the difference fundamentally? Hello,
Sir,
am I
difference
audible?
between what?
If I'm not audible, just tell me. I mean, like, hello,
Yes, sir,
just
you're
please,
audible. Sir,
yeah.
difference
Great.
between what?
Is it a resistor or a transducer or something else? In the Candace bulb, we are now just focusing on one type of thing which you have been using since ages. And then with the same example, you will be extending so that there is some, some headway to what we want to understand. Yeah, go ahead. Ishan, bolo. Or bhi koi bhi. Anybody, I mean,
The
like anybody is
filament
welcome.
acts as a resistor, but it also acts as a transducer in a bulb because it's helping convert the energy.
What do you mean a bulb? Bulb is basically one which is like emitting light, right? So
Yes, sir.
So there is a tube light, and there is a, nowadays you have this fluorescent bulb, and then you are having say LED bulbs. Can you tell me now which one would fall where and how? Similarly, I will be taking examples of the other things like refrigerator, air conditioner, the fan, so on and so forth. Whether washing machine, are these electrical, electronics, or what? Somebody says it's a mix of all. So I think, yeah, I mean, like, something has been added to make it to so that you have both the electrical and electronics part. But generally speaking, yeah, let's just focus to the different types of light sources which all of us practically use almost every day in life.
Sir,
Yes,
bulb.
Aman. Yes, yeah, go ahead. I mean, all are I mean, like, I would want anyone and everyone to say, I mean, like, whosoever knows it. I can't see the others. Bolo. Aditya Raj, go ahead. Hello. Aniket, Aman, Ishan, Dhirendra.
Sir, bulb would come under electrical and LED would come under electronics.
Okay, why so?
Sir, I put it in. Maybe it's because of how we're controlling the flow of electrons in one.
LED is a diode. Correct. So I think starting point is now somewhat correct. The moment you're talking about semiconductor anywhere, whether it's 3,5 compound, whether it's silicon germanium, or any other type, so there are fundamentally so many things that are different. What are those? Why there was a complete campaign to switch over from this incandescent as well as tube light to LEDs? Anybody? There was a whole campaign, switching over from those incandescent light, to your these types of bulbs, LED bulbs. And I think they are trying to make everything. Anybody who has any idea? Yes, Tarun, Ishan, Bhanot, Dhirendra, Aditya. Am I audible? Am I
Yes,
audible?
yes.
Yes, sir. So was it energy consumption?
Of course, energy. Why energy? Okay, you're coming. हाँ, आगे बढ़ो. Energy.
So energy consumption was reduced, and I think it was CO2 emission, not the last one.
Forget the emission part. Okay, that is, a byproduct. Let's just talk in terms of energy. Why should there be a difference?
So because the simple bulb or incandescent bulb was utilizing, which was giving out more heat than the light.
It was giving more heat
Means
than the light.
it was utilizing more energy in heating up than giving out the
When
light.
you go, I think I really do not know whether you have bought a bulb previously or not. They used to say, okay, 40 watt or 60 watt incandescent bulb is equivalent to 5 or 10 watt or 5 or 6 or 9 watt of your LED. And in between also they used to have fluorescent bulbs equivalent to, so the what so what does that mean? I mean, what they were trying to say?
So basically, they are controlling the flow of electron in the.
No. The whole idea was to reduce power. That is fine. But how?
So because internal resistor, due to internal resistor, high resistance,
No,
more consumption of energy.
Sir,
no.
sir, in case of the incandescent bulbs, initially the filament is heated and then
Correct.
it more amount of power is consumed in that bulb. But in LEDs, what
How?
happened is,
Why? How? Correct. I mean, like that we already know. I've already given you the hint. But how and why? That is what I'm asking.
so because the filament in that bulb acts as a resistor, so and
Correct.
so
So
Sir, the filament of
what
the
is the okay, let's
bulb
go.
is
Let's go
high
again to the
intensity
basics.
because
What
of
is the
the
source that you're using? What is the source? What is the source that you're using, say, for switching for putting on, say, a incandescent bulb? What is the source that you're using? Domestic. इतना तो मेरे ख्याल you have done some courses before. Yeah, Manas.
AC source.
AC source. What? Yeah. Go ahead. और बताओ उसके parameters. AC source.
And sir, as we use AC source, the power that consumed is a square of the current that we give to the bulb.
What is the voltage that you are giving?
So 220 to
In
240.
India, you are giving around 220 to 250. Bolo, go ahead.
220 to 240 volts
250,
voltage.
yeah. What frequency? It's a AC around 220 to 250 because it's different in different countries. That is why we are saying this. I mean, like in some of the other countries, you would find 110. Okay. So in India, that's why I made it very specific. Yeah, go ahead. Hello, you there? So this is not my computer. I really do not. If I'm not audible, just let me know. Bhanot? Hello? Yeah, go ahead. Manas?
Yes, sir. The frequency used in India is 50 hertz.
Yeah. Yeah, now can you correlate some of the things in electrical? Most of the electrical devices that we are talking about
AC, in AC.
is on AC signal having a high voltage. Laptop किस पे अभी I'm not having any power. What is my laptop working on? What voltage are we talking about? Hello? Or your smartphone? Hello?
The DC source.
DC source, what is the voltage approximately of the order of? It can
12
range.
volts.
Few volts. It's not 240, 220 to 240 volt. Fundamental difference. Hello? Sorry if I
Yes, sir.
don't get any. At least you people say yes sir, no sir. I feel as if there's some problem with the network. So moment you are talking about AC, you have all those power sockets. You know,
Yes, sir.
so it is having higher current, higher voltage, AC signal. Whether you talk of refrigerator, whether you talk of washing machine, whether you talk about AC, so on, and whether even you talk about fan, the whole, what does fan has? The motor. While when you're talking about electronics, three fundamental things. Either it's going to be diode, transistor, again, all types of diodes, all type of transistors. Whether so diodes are used from LED bulb to solar panel, solar cells, and and an extended version if you can talk in terms of PNPN or SCRs, which is power electron. So that are like going into a hybrid form. They are very thicker in this thing. So predominantly it is 99.99% or predominantly it is diode and transistor. So moment you are talking about LED bulbs, you're talking about very low voltage, but its luminosity is equivalent. Luminosity is like the amount of light that is being derived from your LED bulbs is equivalent to 40 watt of incandescent bulb. That is what they are saying. So power that is used to get that kind of light, you can get it using these semiconductor uh, diodes, which is what you call a light emitting diodes. The light that is coming is almost the same or maybe even more. That is why I say, oh, it's equivalent to this, but the power that to drive that becomes quite low. That is how, if you do it in millions and almost replace everything, then you're saving a lot of power. Am I audible? Hello?
Yes.
Yes, sir.
Did you get the fundamental difference? Do you use AC in any of the electronics? Hello? Dhirendra, Siddharth, do you use AC in electronics? Do you use AC in electronics?
No, sir, DC.
Okay, and what voltage are we talking about?
20, 40 volts.
Very low voltage compared to any of the AC signals, which is 220 to 250 most of the times. So even when you are charging the batteries here, whether you talk of laptop or smartphone or any other device, you have a step down transformer from 220. You know what is a step down transformer? Banod, Dhirendra, Aman,
Yes, sir.
have you heard about Aditya? Have you heard about step down transformer?
Yes, sir.
What does that do?
So decrease the potential.
The voltage, sir.
Flux, we
Decrease.
decrease the flux.
Flux is very different word. Voltage is the current one. What is flux?
Area into
What is
Straight line
Faraday's
passing
law?
through the given area.
What is the Faraday's law?
So change in flux is directly proportional to the motional EMF.
Huh. So what is EMF? So so is there a difference between flux and, because you should not use, arbitrarily using something or the other. You be very whether you're talking about voltage or whether you're talking about flux. It's two different thing altogether. Now,
The change of the flux causes a change in voltage, sir.
rate of change of flux
EMF.
Okay. Causes a change in the voltage.
causes change in voltage.
EMF.
Produce voltage.
So induces EMF.
Induces. What is the difference between induces and change in flux? Change in voltage. Is there a difference?
I mean, sir, as hello, sir. I
Induces
mean,
matlab what? Please.
electromagnetic voltage EMF gets induced in the coil. Step down transformer has a less number of coils, and as the AC voltage signal is changing, so that changing voltage signal induces EMF, and the magnitude of the voltage decreases, and the power remains constant, but the magnitude of the voltage decreases, and this is what we want.
This is what we want. So basically, when we are charging the battery of our laptop or a smartphone, we are using, because we are using a 220-volt source. But at the end of the day, the batteries are of few volts only, and that is DC. So first of all, there are two things that we are doing: step down the voltage from high voltage to low voltage, and the other important thing that one is doing is conversion of AC to DC. Yes. Okay. Is that clear? So most of the electrical devices that you're talking about is 220 AC signal and so on and so forth. And it's using motors and stuff like that. Unlike electronics, everything is based on semiconductors. And semiconductor, if you give that kind of voltage, and it will get destroyed. What is the band gap for silicon? Anybody? In terms of electron volts? Do you understand that? Have you done those basic courses before? Mansa?
0.7 to 1.1.
0.7 is for silicon.
So 0.7 is for germanium, I guess. And around 1.1, 1.2 is for silicon.
So for any electronics device, do you need that kind of voltage? Like for have you ever used AC for running your smartphone? The answer is hello. Mansa, the answer is don't know.
Sir, no. I mean, we do not use.
We do all semiconductor, whether it's solar panels, whether it's LED, whether it's your tablet, whether it's laptop computers, so on and so forth. None of them are using this thing. Even in the computer that you're using, the moment it gets chips, there is a complete box which again steps down the voltage to convert into DC. So if you assemble a computer, you will come to know. Or if you just unlock the desktop computer, you will see all these things. Moment you are talking about semiconductor, we are talking about very low voltage and DC power supply. Otherwise, how would your semiconductor work? So fundamental difference you should be knowing. It is in terms of AC, and this is DC, this is the voltage, and that is why the power consumption is very low. Why it increases is because you're using loads and loads of these transistors inside the chip. So, but for one, so have you heard? So, like in your home, which of the electrical device or which of the devices uses maximum power? Is it electrical devices or the electronics? Hello, Mansa?
Yes, sir.
Which one uses
Sir,
more power? Consumes more power? When I say
sir,
consumes more power, I mean if you run it, say for say few hours, two different, one electrical and the other one electronic, which one will consume more power according to you? Roughly.
sir, the electrical ones would consume more power.
Yeah, that is why when you switch on the AC, your meter starts. When you switch on your heater, your meter starts going up. When you switch on refrigerator, meter starts going up. Or any other thing, like even when you start warming the water, so on and so forth. Now, this course would be predominantly dedicated to semiconductor-based systems. And as I told you even last time, from semiconductor, what is the next hierarchy? Transistors. From transistors in the digital block. Now, again, somebody talked about operational amplifiers. That is going towards the analog side. So from transistors, you can make digital, and from transistor, you can make the analog. So operational amplifier is when you are going towards the analog circuit design. Manas?
Yes, sir. I understood it. What you're saying, sir.
Yeah. And you will have active devices as well as passive devices. In all the circuits, you have RC as well as active devices. You have resistance. The moment you are having any kind of wiring, you are having some kind of resistance. You always have a capacitance. You can always have a resistance. That is why you probably may have you studied two-port network system, Manas?
Yes, sir. We studied in network analysis.
Yeah. So can you name name few of them?
Sir, we like two-port systems.
Two-port network system, very famous. It is basically used to do what?
Sir, I don't remember it exactly, sir. The examples.
Sandeep, do you know difference between Thevenin's?
Okay, sir. Thevenin and Norton. Okay,
Norton.
Sir.
What current? So please, you have to revise all this. Moment you're getting into digital, you are having active as well as the passive devices. It's the difference lies when you're talking in terms of the source and the power. Electrical devices, you would have resist like in incandescent bulb. It's acting as a resistance. The moment it's acting as a resistance, that tungsten wire, it is basically eliminating heat. So that is acting as a transducer. The moment you're changing one form of an energy into another form, what is that called? Sandeep, Siddharth, what is the basic
So we have
definition?
another class right now.
You're done?
So we have another class right now
Yes, sir. Computer
with
application.
the dean. So he's asking.
Okay. Thank you. Maybe next time, huh?
Yes, sir.
Okay. Bye-bye. Thank you.
Aman. Aman.
Jitendra,